views of each of the perspectives that they bring. And the whole idea, and this is a spoiler alert, the whole idea is as we compare and contrast and look at all of the uses of spectrum, and we do have a very broad range in front of you, you will see that there is a reason why we have these different ones. So with that spoiler alert at where we were going, that's not where we're going to immediately go. We're immediately going to go to why my spectrum is the most important spectrum and should be allocated more spectrum to accommodate the uses that are applied. And since there is only a finite amount of spectrum, that means that others who are advocating that their spectrum is the most important are clearly in error. And it will be pointed out their deficiency as part of the discussion. So with that background and setup, we'll jump into the panel itself. And this is me. I'm Dennis Roberson. And I have many roles, but one of them is my namesake role as the president and CEO and founder, if you can imagine, of Roberson and Associates. And next to me is Tracy Bisweier, and she is the Vice President and Associate General Counsel of NCTA, the Internet Television Association. And hopefully you all have read the bios of the individuals, so we won't spend a lot of time on that. If you haven't, then your homework assignment is to read the bios and the distinguished backgrounds that each of our panelists have. But Tracy, coming from the cable world, will be advocating a certain position around that and why that is so important and why, in particular, Wi-Fi is by far the most important wireless technology. Next to Tracy is Andy Clegg. Andy Clegg is from Google and has a multifaceted background. He actually is the CTO of WinForum as well, and even serves in academia on the side. So he has many hats that he wears. Andy is with Preston Marshall, who you heard from this morning, is very involved with CBR. And next to me is Tracy Bisweier, and she is the Vice President and Associate General Counsel of NCTA, the Internet Television Association. And hopefully you all have read the bios of the individuals, so we won't spend a lot of time on that. If you haven't, then your homework assignment is to read the bios and the distinguished backgrounds that each of our panelists have. But Tracy, coming from the cable world, will be advocating a certain position around that and why that is so important and why, in particular, Wi-Fi is by far the most important wireless technology. Next to Tracy is Andy Clegg. Andy Clegg is from Google and has a multifaceted background. He actually is the CTO of WinForum as well, and even serves in academia on the side. So he has many hats that he wears. Andy is with Preston Marshall, who you heard from this morning, is very involved with CBRS. And he will, of course, be pointing out that if all of the spectrum were in CBRS control, then it would be much, much more efficiently utilized.
Less caffeinated, Preston.
The second Andy in our panel, Andy Droz, is the president and principal scientist of Andro, which is a very significant defense contractor sitting outside the gates of Rome Research, the Air Force's Rome Research Center. And he will be representing all of the Department of Defense. So he has a heavy, heavy weight on his shoulders. And he, along with Cheryl Genko, sit in the middle because, for reasons totally unbeknownst to me, the cellular world and the DoD use of technology seem to be in the crosshairs of most people, so we've carefully positioned them in the center so that they could receive the crossfire from both ends of the panel. Jackie Green represents the ultra-wideband interest. She's the director for Nexonics Design, but she is representing the Ultra-Wideband Association and the whole ultra-wideband world. And I will spoil this one. We sort of set this up for someone else to say this, but the question that should be in your mind, ultra-wideband, is that still a thing? And she will explain why your great-grandfather's ultra-wideband is nothing related to what ultra-wideband is today, and why ultra-wideband really is the coming technology, and it is the most shared spectrum of all. And in fact, as she will use a total, I won't spoil your term. I won't. Yeah. And finally, Michael Calabrese. And Michael, some of you should know, all of you should know Michael. Michael is in the press every week. He is a highly profiled individual. He, in fact, along with several of us, are involved in creating the PCAST report that established the CBRS and a few other things, so it's a fun position that he has. But he will be advocating a slightly contentious perspective. So with that, let me turn things over to the panel, and for your viewing pleasure and reminder, I put everyone up on the screen so that when you get to the end, and there are opportunities for questions, you can address the questions to the individuals if you've at that time forgotten their names. So with that, let me turn things over to Tracy.
Sounds great. Well, good afternoon, everyone. Again, my name is Tracy Biswayse. I'm with NCTA, the Internet and Television Association. NCTA is the principal trade association for the U.S. cable industry. Excuse me, just in case you can't hear me. NCTA is the principal trade association for the U.S. cable industry, and the cable industry represents 80% of the nation's households and provides more than 200 cable networks. The cable industry is the nation's largest residential broadband provider. After investing more than $310 billion over the last 2 decades to build its high-speed networks in both rural areas and in urban communities. Cable companies also operate some of the nation's largest Wi-Fi networks, and several of NCTA's members offer competitive wireless service as mobile virtual network operators. So you may be wondering, how does the cable industry use spectrum? Why is it relevant in this industry? As I mentioned, NCTA members do operate wireless networks and rely on spectrum to extend the reach of broadband networks. There are high-speed, high-quality broadband networks through Wi-Fi, and also offer competitive mobile voice services. And to do so, consumers are able to experience the full benefits of their networks, which rely on both shared licensed and unlicensed technologies. And for many years now, with technological advances, as there have been changes in consumer behavior and how consumers communicate, and this has caused Wi-Fi usage to swell over time. And with that, over half of US and global traffic travels over Wi-Fi connections, and that's wired or wireless traffic. In addition to that, for many mobile users, the internet has become synonymous with Wi-Fi. And that's the case where over 80% of cable operator traffic is offloaded, mobile operator traffic is offloaded to Wi-Fi networks. And as of 2022, the average US household owned 16 connected devices. So the Wi-Fi demand continues to surge and increase, and as so, the demand for more access to spectrum via unlicensed, shared license, and other coexistence frameworks has bubbled up. And I'll have plenty more to say, but I'll pass things over to Andy.
Andy, number one.
All right. Thanks, Tracy. Thanks, Dennis. So I represent the Citizens Broadband Radio Service domain, CBRS, which I think most people have heard of. but may not be thoroughly familiar. So, a few years ago, it was realized that the band that CBRS is in right now, it was allocated for federal government use and specifically for radar use, and even more specifically for naval radar use predominantly. And it was realized, like, why are we holding all of this spectrum from being used around the country when it's just the Navy using it along the coastline? Why aren't we using it in the rest of the country? It doesn't even have to be shared. It's just not being used in the rest of the country. So some smart people at NTIA put it on a fast track report of spectrum that could be reallocated. And then the PCAS committee that Dennis and Michael were on, and Preston as well, came up with a unique plan for sharing this band. And it's unique for a couple of reasons. One is it's shared, but it's also unique in the licensing framework that's being used. It's sort of the best of all worlds. There's a component of it that is, it's licensed, called priority access license. So you buy a license from the FCC at auction, and you get a 10 megahertz chunk or up to 40 megahertz in a particular area, and you're protected from interference. There's a second tier called GAA, General Authorized Access, and basically you're allowed to use any spectrum that a priority access licensee isn't using, or the DoD. And so it's kind of a use it or lose it. Like, even if a PAL bought a county at auction, they're only protected in that county where they're actually using it. If there's a corner of the county where they haven't deployed cells, the GAA service can go in and use it. And so this is this unique three-tier architecture, where the tiers being DoD, they're the bad guy. They're actually the good guy. They've been great. They've been great to work with. They've worked with us this whole time trying to.
Come on, don't be nice now.
No. Well, I will say one negative thing later, but so the first tier is the incumbent, which is mostly the DoD. Then there's a priority access licenses of CBRS, and then there's a GAA tier of CBRS. So there's three tiers. So we've been going full commercial service for just about 4 years now, and it is by far the most widely deployed spectrum sharing technology anywhere in the world. So, we all talk about spectrum sharing. I often laugh at people put panels together about spectrum sharing, and there isn't a single person on the panel who has ever built and deployed a spectrum sharing system. That cracks me up when they do that. Thank you for not doing that, Dennis. But Google was one of the principal architects of CBRS. There are a few companies that I won't mention that were also involved to some extent or another. But we're now up to about 378,000 total base stations or access points they call CBSDs, Citizens Broadband Radio Service Devices. And just to put that in perspective, that is greater than the total number of cell towers that have been deployed in the history of cellular technology. So we have sort of mass marketized, 4G, 5G, and proprietary deployments at a scale and a speed that hasn't been done in any other band. And we've been able to make great use of spectrum that otherwise was not being used. And again, I do have to say it was a great work of a lot of people, the NTIA to identify the band, the PCAS to come up with the framework. Like I mentioned, DoD and NIST and ITS and FCC and other components of NTIA all work together to create a framework in CBRS that works. And I do have to announce, Preston alluded to it this morning, but I think one of the lasting legacies of CBRS is that we've proved that you don't have to pile conservative assumptions on top of conservative assumptions to share spectrum, because we did that when we created the initial rules and standards for CBRS, but with great work being done by all of those organizations I've already mentioned, we've gone back, we've realized there has never in the history of CBRS been a case of interference caused by CBRS operations to DoD or to any of the other incumbents. We've recognized that, and we've gone back and rewritten some of the sharing rules and frameworks and propagation models and things like that to sort of relax some of the requirements. And those changes, you'll hear a lot more about those in the coming basically month or two. You'll hear a lot more about those, but it's a very dramatic improvement in CBRS and reduction in the amount of time that CBRS is going to be preempted by DoD activity. But again, this is all the result of all of the components working closely together. So I think the lasting legacy of CBRS will be improvements in the assumptions that go into spectrum sharing models. Other Andy.
Hello, everybody. So as Dennis mentioned, I'm going to sort of give a Department of Defense perspective. I'm not speaking for them, but I'm going to sort of reflect some of their thinking, some of their philosophy. And you have to look at it from the standpoint of we are considering policies, we're considering a variety of things, but fundamentally, we're trying to look at how can we leverage the science side of this, meaning what are the best ways to implement, test, validate, and deploy actual DSA, DSS systems. So I'm going to come at it from that point of view, and I'm going to touch upon a couple of newer things that are happening within the DoD. But I want to start out by saying that the DoD represents really the most heterogeneous, the most optimal access to spectrum and spectrum management needs and spectrum sharing needs. With the diversity of applications, you know, from radars to communications to satellites to sensors, that's the most challenging environment. And the funny thing is that all of that happens at once. And if you look at the actual theaters of deployment, all of those things are operating at the same time continuously. So how do you manage all that? Well, current static set it and forget it policies we know don't work. They work up to a point, but there's interference, there's contention, there's congestion. How do you resolve that? And that's part of the problem. So we're looking back at some of the more fundamental scientific methods of how to dislodge that problem and enable dynamic spectrum sharing to happen in the real world under dynamic conditions and real states. So we do have a number of solutions already in place that are being tested and validated, and we're collecting metrics on these solutions. But again, the number of use cases is immense. There are so many different conditions and states. So how do you encompass that? How do you capture that? And how do you metricize that? So there are challenges ahead. Nonetheless, we're looking at it from a research, development, science perspective and kind of rebuilding the thinking process here. So the work that we do, the work that I'm involved in, is really involved in dynamic spectrum sharing, access, and management. But there's an emphasis on trying to incorporate better policies. Can we come up with a way of generating policies based on the field of use or the use cases? Are there ways that we could define the policies in a more practical way and constrain them further as needed for geolocation, for power, for allowed spectrum usage in a particular part of the world? So all of these worlds are colliding as we speak, and there's no firm resolution, but there are some ways forward. My esteemed panelists are also looking at different ways of making that happen. But I think the idea here is that we've got to think of it in a little of a different way. Rather than look at it as sharing and oversimplifying the problem, I think we need to look at it as a set of metrics. And there are different levels of metrics. There are mission metrics, there are performance metrics, key performance parameters, all the things that we've been dealing with in our industry. I think we need to kind of revisit that in a little different way and look at it as a multi-objective kind of a problem. Is how can we achieve the best result looking at all of these different parameters? And again, it comes down to things like mathematical search spaces and crazy stuff like that. We're not going to talk about that here today, but it really comes down to a better way to reorganize the model, the system, and derive and distill what we need to make decisions. So the Air Force talks a lot about data to decisions. And I think that's what I'm trying to capture here, is coming up with a better, smarter, more intelligent, more tried and true method of doing data to decisions based on actual data in real time, modifying things on the fly as needed, and then making those decisions to be best representative of what you're trying to achieve in terms of mission, performance, and other factors. Very, very challenging. In fact, a lot of work's been done in the DSA realm on being accessible to DSA. We have a couple people here that have helped author those papers and those ideas. And we want to bring that out and tease the ideas out more and make them more pragmatic for usage and deployment and testing and validation. We have to keep doing this. If we don't do this, we're never going to achieve the kind of new spectrum world that we're looking at. And start thinking about autonomy, start thinking about security, start thinking about data throughput, quality of service. All of those metrics have to be considered at once. Again, how do you do that? That's what, again, the DoD is trying to do. They're revisiting, regurgitating, and kind of rejuggling the whole optimization process to try to figure out what are the most important parameters and in what order can we achieve that. So the approach that I'm talking about here does not take away from any other approach. I think we're looking at embracing all different approaches, whether it be UWB to cell and everything in between.
Oh, you're not supposed to do that yet.
But there are problems with some of those approaches. No approach is foolproof, no approach is bulletproof, and therein lies the problem, is we need to tease out some of these issues and talk amongst ourselves, we being the experts and the community being the experts, to come up with the best solutions moving forward. So let me kind of leave you with this. A lot of what the DoD is now trying to do, and the federal government, and I'm involved in several different groups that are looking at this, is how can we leverage machine learning? So what we are doing is trying to get the nexus of radio frequency, wireless, machine learning, AI coming together, and trying to use that as the basis for redefining the problem in such a way that it accelerates the future spectrum and the spectrum modernization that we're all talking about, from the NTIAs to everybody in between, the DoD, and here we are today talking about it. I hope we're not talking about this in 20 years from now, because in 20 years I think we have to have change, not see change or anticipate it, but actually have change. So with that, I'll turn this over to Cheryl.
Thank you. Thank you so much. So someone said to me in the hallway, up until your panel, Cheryl, I've heard all this before. I could have fallen asleep 10 years ago and woken up today, and I wouldn't have missed anything. Well, I think what we're trying to do on this panel is wake us all up and sort of get on the fact that spectrum now, we got the hard problems, okay? The easy spectrum has been allocated. We've got some more work to do in the short term and the long term, but now we've got to do the really hard stuff. And what does that mean? It means engaging in technologies and different types of approaches to the problem. So Andy here, he talked about metrics and looking at problems all at once. Well, unfortunately, Dennis, I totally agree with that. We've got to look at mission-oriented approaches to spectrum. So why am I here, right? Well, I'm here to talk about the agile frequency use globally of cellular systems. You know, we have a lot of technologies in our radios, from MIMO to beam steering and power consumption technologies that are being utilized across the globe. We need a diverse set of solutions to take us into next G, or even to do these moonshots that are being talked about all week, with the culmination on Friday with the Wizard Group. So before we even begin, like, how many people have at least one cell phone? Come on, raise your hands. Come on, this is school. Okay, how many people have more than one? Okay, yeah, that's what I'm saying. Some of you are afraid to admit it. And then also lastly, to my other colleagues on the panel, who has tried to hotspot? Who has hotspotted with their cellular phone? There we go. Okay, so why is everybody's hands going up? Well, that's the power of cellular technology in concert with these other technologies. So again, sorry, Dennis, I'm going off script. The professor is going to give me an F.
She is much too kind.
The professor is going to give me an F. But what's the status of 5G in the United States? Okay, there's over 100 cities being served by 5G millimeter wave, over 300 million in low band, and almost 300 million in mid band, and 40% of all LTE are 5G millimeter mid-band ready. That's pretty amazing. The other thing that's happened over the course of this time is the launch of private networks, okay? Factories, 3,900 factories in the United States serving more than 500 workers each, over 2 million people on a private network in factories. I had to do a little math to compute this, but there are 22 ports handling a total of over 1 million 40-foot containers. So your homework, everyone, is look up what a TEU is, because it was very hard to compute that. But anyway, and of course, you know, sports arenas and venues and Billy Joel concerts where over 5 million people are using private networks. That's not the only thing that's happening, right? This comprehensive approach, right, to spectrum for capacity, for coverage, continuity, and the quality of experience. I think everybody is touching on that as well. But those expectations only will get higher and higher as everybody gets more and more use and, you know, sort of drinks, you know, gets addicted to cellular technology, right? So at Ericsson, I was surprised by this. I had to do some homework because I wasn't exactly sure. but there are over 230 global bands that Ericsson's radios service. Now, that's a lot of frequencies. That's a lot of different technology. That's a lot of work, and that's why Ericsson is by far the most engineering-oriented company I've ever worked for. But we're doing innovative things every single day, not just in the future, perhaps with some of the NSF work that's coming and whatnot, but we are working on carrier aggregation for 4G and LG systems. Can that be used in the future, perhaps with a DoD system? Dynamic spectrum sharing, but not in the way that a lot of people talk about. Maybe later Dennis will get us to talk about what does dynamic mean? Is it on a time base? Is it on a geography? What is that time base? And what's that degree? What's that degree of I can't pronounce that word, dynamism. How do you say that word?
You said
Did I say it? Oh, great. I can never report. So anyway, you know, there's all these technologies, and we're improving, the cellular vendors, Ericsson, are improving the uplink performance every single iteration of our radios. So the first half of 5G, I'm almost done, Dennis. The first half of 5G, you know, we launched in the United States with a peak of investment, about $39 billion in 2022. It enabled mobile broadband, fixed wireless access, wireless WAN, 2.5 million devices on the wireless WAN right now. And of course, my favorite, which is the private networks. One of my personal goals is all these chip manufacturers and factories that are coming back stateside is to put them all on private. That's my personal goal. And we've had a lot of architectural changes. I don't know if you guys are aware of the AT&T deal that Ericsson announced in December, but it was a historic $14 billion deal that changes the face of Open RAN for the United States and the globe. And I'm very proud of that because that took not only a lot of work, but it's really enabling a lot of innovation in the future. So with all this, we need the spectrum. We need to work together on the moonshots that have been launched by all the various agencies. I'm staring right at John again. And we need to start to put that time scale together. What can we do today? What can we do in the near term? What can we do in that 12-month framework? What can we do after that? And really reinvent how we approach spectrum, because the binary solutions or binary scenarios to spectrum use cases aren't going to work anymore. So with that, I'll turn it over to Jackie.
Okay,
Where's the-
let's see, this microphone?
Yep.
You all hear me? I'm an audio geek, so I worry about my mic. So I'm glad to be here today and to be able to participate in this important discussion about spectrum and the wireless topic that we all are interested in. A lot of you probably don't know who I am. I come from a slightly different background maybe, and maybe a little bit of a different perspective. I like to think about that game, that one of these things is not like the other. That's me, but that's also the topic I'm talking about today. UWB is one of those things that is not like the other. It is actually not like any other wireless that's in use right now. And there's the obvious topic that of the super low transmit power, but there's the thing that people don't think about, and that is the fact that UWB is not a continuous carrier wave technology. That results in some very significant advantages from a performance and a utilization standpoint, where it can operate much differently than other types of wireless technology. And when you can operate differently, sometimes you can solve different problems and do them in a better way. So let's go there to the room who wants to say, well, we thought UWB was dead, right? And that's an early mistake. And that early mistake was that the original people wanting to do UWB thought, oh, let's replace Wi-Fi. Why do you want to replace Wi-Fi? Wi-Fi's great. We all use Wi-Fi. And what happened was they didn't consider the right technical advantage. They got sold on the bandwidth. I mean, it's like crack. It's like, wow, you're hitting the lottery. You get this giant amount of bandwidth. So you're all going to go there, and you're all going to try and make that bandwidth work. And that was the wrong approach. That wasn't how to make UWB work. Truthfully, people kept working in the background since the mid-2000s, me as well. I started working on UWB in 2000. And they worked on developing it into a method that has been silently growing and performing, and is already secretly coexisting in the spectrum to the tune of 1 billion devices and growing. So people don't realize it, right? Here's an interesting fact, one small diversion. Wi-Fi. It's been about 20 years, this is what I'm talking about, from like the 2004 time to now. Wi-Fi followed pretty much the same path. Wi-Fi took about 20 years to go from concept to being pervasive in phones. Same schedule. Now, here's UWB. And we're here, and we're ready to operate, and we're ready to take a place at the table, but we actually, not just ready, we are at the table. So, UWB is very misunderstood. People talk about how great it is that the FCC opened up 6 gigahertz for unlicensed operation. Excuse me, oops. Unlicensed operation has been, UWB's been working there and elsewhere for a long time. And it's been coexisting without causing any problems. No reports of interference to other devices. And it's a testament to coexistence and the power of the technology. The fact that people didn't realize that there was this unlicensed device already working perfectly fine, performing better in many cases than other devices can perform, and coexisting. And I want to really keep saying that word, coexisting, because coexisting does not mean sharing per se. Sharing is sort of implies 2 parties who are participating in a transaction. It can oftentimes be like an exclusive temporary use, and that is not the same thing as something that is just operating fully in the underlay without interfering with anything else, and it's operating in the same space at the same time, and it's just there. So I like the word coexisting, and I bought one. The first thing I did when I got here, I bought one of the coexist t-shirts because, yeah, let's try and coexist. I think that needs to be a priority first. And then we can talk about how to share and everything else, because not one thing, not one method is going to fill everything. Sorry, Dennis. But let's talk about, so we don't have that continuous carrier wave, so we've got a real advantage sometimes when it comes to physics, and we do have this super low power. And the super low power has advantages in some situations. If you can control your sphere of influence, if you can control the amount of multipath that you're getting back, you can actually do a better job than when you raise power. Early on in my UWB days, I thought, oh my gosh, I just got to get more power out of this thing. I want to go farther. And I raised my power. I got a temporary license, and I experimental license, and I raised the power, and I tested it, and it was a disaster. It was a disaster because it completely changed the physics of how the pulses were hitting, and you know how I had to track it with my filters and stuff. Sometimes lower power is better. So I'd like to caution everybody in the room to remember that that sometimes it's better to not replace a technology that's already existing on an unlicensed basis and working really well with technologies that are actually going to require more power and more spectrum. UWB is asking for more spectrum, and can probably not do quite as good a job in many of the applications when you're talking about precision, location, fine ranging, low latency audio with real-time, high-quality performance, device density. If you have a lot of devices, even if it's your own devices, and you can't, if the power's high, you can't put a bunch in the same space, right? So there's a lot of things to consider that are advantages with this technology. But there's one more thing I want to mention that's got nothing to do with wireless, really, and that is that UWB is good for the environment. The extremely low transmit power means that you're using way less batteries. And if you're using less batteries, I mean, come on, the landfills are filling up. My junk drawer, it's crazy with the batteries. we should all be mindful. We should all be considering energy consumption when we're making our decisions about what kind of wireless to use. And we should have energy consumption become a measurement of importance when we're making our decisions about wireless. So, running out of time, I want you all to consider that UWB already is here. It's already coexisting. 1 billion devices and growing very rapidly. It's now integrated into chipsets along with Wi-Fi, along with Bluetooth that works well with everything, likes to share, as well as coexist. And it's a key tool in the wireless toolbox. So instead of hitting everything with a hammer and brute forcing it, I think we should be looking at picking the right tools for the jobs.
Great.
All right.
The cleanup hitter.
There we go.
Well, see if I can make a mess while cleaning up. So in keeping with Dennis's admonition to be provocative, I can honestly say that unlicensed spectrum sharing is the only technology and policy that can ultimately deliver bandwidth abundance at an extremely low cost. We need to prepare now for a world where literally everything is connected, intelligent, frictionless, ideally, untethered, and affordable. But how do we get there? So we can just really, in some way, stay on our current path. Like connectivity today, the most distributed, efficient, and affordable path to wireless bandwidth abundance is an exponential increase in unlicensed spectrum access. We just need to give unlicensed far more regulatory room to run as ongoing trends in technology and infrastructure continue to facilitate its inevitable predominance. And I'll come back to that in a minute. But first, I think it's just important to establish that today, it's already beyond dispute that Wi-Fi, relying on unlicensed, is the workhorse of the internet. Unlicensed carries the vast majority of all internet traffic to and from end user devices. Waving this device as someone else did, 80% or more of the data traffic on smartphones and like 100% on tablets and laptops, for example, never touch mobile carrier spectrum or mobile carrier infrastructure. It just would not be economic. Unlicensed optimizes spectrum frequency reuse and hence overall spectrum efficiency. Unlicensed is clearly a boon for competition. I bet most people here don't realize today 3 cable companies already have more than 15 million mobile subscribers using networks that rely first on Wi-Fi. Charter, even just a year ago, reported 87% of their customers' mobile traffic is over Wi-Fi, not over the cellular, and I bet that's going to be above 90 really soon. It's a boon for innovation. We will soon see most enterprises and venues leveraging the multi-gigabit throughput and 5G equivalent capabilities of Wi-Fi 7, available by the end of this year, to customize and control their own IoT networks, not buy them off the shelf. Initial CBRS deployments already suggest this. More than 80% of the 400,000 CBRS access points that Andy mentioned, deployed by more than 1,000 users, are using the GAA portion of the CBRS band, General Authorized Access, which is akin to unlicensed. And finally, obviously, it's a boon. Unlicensed is a boon for affordable connectivity. Imagine how much less available and more expensive mobile device connectivity would be without open access to this free public highway. But we've actually only just begun to tap the enormous potential for shared and particularly for unlicensed access to the airwaves. And I'm sort of looping in UWB here, so you're getting a bonus. Looking ahead, there are two waves of unlicensed innovation, one in policy, the other in technology, that I believe will lead to bandwidth abundance despite steadily growing demand. First, policy. The concept of use it or share it, as Preston Marshall mentioned this morning, can and should be applied to every underutilized band. The Navy band was just the beginning. 6 gigahertz is another example, of course, including its layered approach to unlocking enormous bandwidth while working around tens of thousands of incumbent fixed links. So stop and think that 6 gigahertz now has 3 categories and perhaps soon 4 categories of use: low power indoor only, very low power anywhere for peripherals, standard power, which can be outdoors, also under under control of an automated frequency coordination system, and now proposed is geofenced VLP at a higher power than regular VLP. So this multi-tiered approach to opportunistic low power access to unused spectrum capacity should be extended to more lightly used bands, one after another. This use it or share it approach can be extended most quickly through an LPI underlay across all bands where incumbents don't rely on indoor operations. This should include most federal, military radar, satellite, and fixed wireless bands, certainly. In addition, an enterprise should be free to use any band in a contained access facility. Amazon is a great example. In its fulfillment centers, it has exclusive control, so it controls all its thousands of robots and operations with unlicensed spectrum. The second driver of our unlicensed future will be an already foreseeable confluence of advances in technology and infrastructure. These include what Andy mentioned earlier about more granular GIS propagation modeling that accounts for clutter, building materials, and more, a proliferation of fiber and backhaul that will further accelerate network convergence and allow Wi-Fi to act even more as a sprinkler system for connectivity everywhere, distributed cloud, advanced computing devices, and soon, of course, AI. Crowdsourced spectrum sensing can also help devices determine what spectrum is available and optimal at a particular place and time. So in sum, to end, as networks converge and policy and technologies advance, we can effectively begin the overdue process of delicensing the airwaves. The growing predominance of unlicensed connectivity will be the rocket fuel for the wireless future we need.
There we have it. Our panelists were much, much too nice, which I feared. They're such nice people. But hopefully they've also shared a great deal of insight with you. I would have to point out a few things, though, that have come to light. And we'll start with Michael. Clearly with what Michael has just shared, and to some degree what Jackie shared, I don't know why we need all that spectrum concentrated in the cellular world or with DoD. Would you, Cheryl, and you, Andy number 2, like to respond to why you need so much spectrum, given what you've heard from other members of the panel?
I'd like to chime in too.
Okay, and well, Andy, both Andys can chime in.
Well, we're starting, go ahead.
Yeah, the first thing that comes to mind is what I said at the onset was with all of the diversified uses, all of the dynamics that are occurring in the process, with all of the changing conditions, with everything that's going on that's constantly changing, nothing is going to stay the same for very long. You have a situation where you need to kind of predict what's going to happen. And that's something else that I think we haven't touched on, but I want to kind of bring that out, is that with the complexity of what we're dealing with, at least from the DoD side, we need to have something that can monitor, adjudicate in real time, look at all of the different use cases and applications and the dynamics going on, but also be able to predict ahead a little bit of what's happening. And I don't know if we can achieve that with one solution. I think there has to be a myriad of solutions that come to play here because the space is so complex. You know, Occam's razor said the simplest solution is probably the right one. I don't know if that applies to the spectrum domain. I think we have a situation where things are always on, working, they coexist, they operate, they commingle, they interoperate, they don't operate, they contend, they congest. I mean, everything I just said, every adjective I just muttered is kind of defining the problem. That's the real world. And I think we have a situation where we have difficulty monitoring those states and figuring out what to do next. So I'm looking at this from the standpoint of what can we learn about the way systems operate and what toolboxes can we bring to this. Notice I said toolboxes, not one tool, but toolboxes of tools. So this is kind of a meta approach that we have to take to kind of come up with this. Again, I'm sort of diving into the conclusion of where we might end with this, but there are some solutions that are better than others. I don't know what those are yet. I think mine is, but we're supposed to say that.
Go ahead, Cheryl.
I'm very eager. So very eager, thank you. So part of the work that I do for Ericsson is with the DoD and with NATO. And a little plug for Milcom here in Washington, D.C. in October. But nonetheless, some of that work, we have to take a look at this from the DoD's perspective as well as from the commercial's perspective. Because if we're looking at utilizing commercial off-the-shelf technologies for our warfighters, the minute they go OCONUS, outside of the United States, there's a big problem, okay? One thing I'll say is 6 gigahertz in China is cleaning our clocks as far as the DoD goes. So yes, it's nice that we have all this unlicensed spectrum, but we need to open it up, for more investigation in that area. The other thing I want to point out is I've never learned so much about geography until I started working with the DoD. Now that sounds silly, but nonetheless, I learned where Serbia is. Now, if all of you, okay, no, I'm serious, I'm 100% serious. So if you look on a map where Serbia is, it's completely landlocked. Why is that important to the DoD? Well, if there's some kind of incursion there, they're going to have to rely on the infrastructure that exists in country, okay? And what does that mean if Serbia is not part of the EU or doesn't adopt the 5G toolkit? It means quite a bit for the DoD. So sort of my perspective and learnings that I've had as an Ericsson employee, working not only with the commercial deployments across the globe with NATO and the folks in R&E, but also with AT&Ts and Verizons of the world. And I think we got to all open our mind that this is not a one-size-fits-all thing. This is not just something that has to happen stateside, but we've got to really be able to open up how we share, use those technologies. I'm the engineer, those of you who don't know me, I'm the engineer who says, somebody says, this can never be done. I'm the one who says, sign me up for that, I can make it happen. So let's all put our thinking caps on as we go through the rest of this week and talk about innovative ways to really make it happen.
Can I add something to that, too?
No, not until after Andy.
Yeah.
He's gonna die.
Just one point that Cheryl made that's really, really cool and very important is when you start looking at the interplay between military, federal, and civilian site systems, and you're now adding the complexity of communications, radar, sensors, IoT, and all of those, you can start to see how this complexity builds up. And we have to come up with a better do no harm policy, if I can call it that. I don't know what that means yet. We've actually developed some do no harm policies, and we put them into practice and we test them out. But I think we have to do better than that. I think and I don't know what the answer is, and maybe it's one of the solutions that we have that'll get us closer to that. But that's something we have to give more thought to, is what does that mean, do no harm? And you can look at it from different perspectives. In the past, we used to talk about temperature interference and things like that. There are other metrics that we need to consider. But I think we've got to measure the real world and get a better understanding of what's happening and figuring out how to adjudicate this more intelligently. Again, that's where I'm coming from, is kind of bringing that AI piece into this, for lack of a better phrase. But we need better intelligence in the system to figure out all of these parameters at once and lock load and do what has to be done.
Better sensing like from UWB.
Maybe.
Go ahead.
You said that.
Andy's number one.
Yeah, I mean, it's good. Ericsson, I think, is getting more enlightened about spectrum sharing. That's a good thing. But one thing.
That's because I'm here now.
Yeah, that's exactly, Cheryl. But one thing Cheryl said should be an embarrassment to the cellular operators.
Uh-oh.
She said that their equipment operates on 231 different bands.
230.
230 different bands.
Yeah.
The vast majority of those bands are exclusive licensed spectrum. You can think of the cellular operators as one giant UWB device that cannot coexist with anybody. They can only use their own spectrum. Even here in the US, their spectrum appetite grows without bounds. They got the cellular spectrum originally, PCS, AWS-1, AWS-2, AWS-3, 600 megahertz, 2.3 gigahertz, 2.5 gigahertz, 3.45, 3.7, and the millimeter wave debacle.
Yeah.
You've got all of these bands, and you want more. And it's impossible. It just can't keep happening. I think spectrum sharing, well, first of all, you need to find a way to reduce the spectrum demands, densify your networks or whatever. But also, it just cannot physically, you cannot keep growing at that rate without finding ways to coexist with the rest of the spectrum.
Moment of rebuttal, and then Michael.
Oh, she agrees.
No, sure.
No, I do not agree. So first of all, thank you, Andy. Andy and I always are pretty fiery when we're on these panels, but nonetheless. So, certainly those 230 bands are both TDD and FDD. They're global bands. Okay, they're not all here in Washington, D.C. So, let's take a look at what does that really mean. And what it really means is that with enough technology expertise, we can have a mission-oriented, we can have a global solution to spectrum and to technologies that not only serve, cellular's appetite, but the DoD's and other folks here on the panel, their needs for spectrum as well. So that's my moment of rebuttal.
Michael.
Yeah, so with respect to, there's this whole debate around, military spectrum and high power wide area exclusive use. Many of you may know the reason that the FCC's auction authority has expired for over a year now is because the mobile industry on the one hand and DoD on the other are at odds over whether the military will be forced, off certain spectrum in lower 3 in particular. And this is a wholly unnecessary diversion from the path to spectrum abundance that I was outlining, right? Because for one thing, you don't need like this high power, wide area exclusive use anymore. That was an industrial policy that began, right, with auctions in the early 90s. Well, mission accomplished. We have coverage over wide areas everywhere. What we need now is more capacity, small cells, where you need the capacity. It's why, for example, so much of AT&T spectrum is not even in use at all out beyond the metro areas, because that's not where you need capacity. So that's why CBRS is such a great model, the 3 tiers, because you got Verizon was the largest, acquired the largest number of PAL priority access licenses in the CBRS auction. So you could certainly just have to change the model to, you can use military spectrum at lower power on a more localized basis, including for cellular, where you need capacity, plus 1,000 other uses by enterprise and so on, and have an opportunistic tier, which is in CBRS called GAA, as I explained, but is effectively unlicensed for the schools and for all kinds of other uses. So we can have it all, but we need to move on to spectrum sharing, particularly where it should be obvious that an entity like the military is not just going to divest itself of its spectrum.
Tracy, you are grabbing the mic.
Yeah, just to second what Michael said, there are plenty of new technologies. There are a lot of technologies that have flooded the various wireless waves, and the way to keep up with those technologies is also to advance not only on the technology side but the policy side. The policy framework should keep up with the increasing use of the airwaves, and as we've mentioned, both the CBRS band, which has figured out a way to coexist and to use dynamic spectrum sharing, as well as the 6 gigahertz band for Wi-Fi, have both figured out ways to coexist and for multiple users, new users, to enter the marketplace to increase the competitiveness of use cases, and to do so without disrupting the critical incumbent users like the federal government. So just wanted to chime in there, and I know this is supposed to be a little, kind of more, maybe disagreeable, but I'm just, I think I'd say that the U.S. cable industry, we are, so flexible that we have espoused a lot of these, kind of coexistence and sharing views where there are, a number of ways to think about sharing.
As I pointed out, the panelists are much too nice, even with all my instructions to be absolutely rancorous.
I agree with Tracy on the policy and the technology.
Exactly.
But where I kind of disagree maybe to some extent is, and I've heard this before, okay, so technology is always evolving, right? It's always fast-paced. We know this. Faster than ever. Policy isn't. It's kind of like on, sitting there. It's not changing. Part of the problem that I have with policies and regulations and things is that when we go back to some of these solutions we're talking about, and I kind of want to challenge my panel members here, when you start talking about implementing something, you talk about Wi-Fi, you talk about UWB, there are things that we need to consider with regard to, well, what's the range, the distance? We can adjust power and we can extend range and do all those wonderful things, but at what cost? Are some of these things that we're trying to deploy, some of the infrastructure needs, are they going to bring in added expense and complexities that are going to make it, non-starters? And I think that's something that we often overlook is the economic side of the argument. Yeah, we can deploy all these things like 5G, but we need a dense network to make it really work. So I just want to challenge the members of the panel. What do you think about the economic aspect of this, the infrastructure, the complexity, and how that plays into what we're trying to do to make dynamic spectrum sharing a real thing?
Well, why are you worried about money? We just put in $42 billion for BEAD, so I mean, the money is there.
Yeah, please.
Please.
So
Jack.
when you ask the question about, especially when you're talking about, well, do you need more power, do you need more range? If you think about the wireless ecosystem as like a tree, and the cell or federal users are kind of like the trunk, and the Wi-Fi is kind of like the branches, and the UWB and other unlicensed things are more like the leaves, and the IoT and the edge devices. You need all those pieces to have that tree, right? But I would challenge what role does the actual technical requirements or performance play in the construction of that tree? Because in some cases, you've got the leaves, from a technical standpoint, far outperforming the technology that's existing in that trunk. And that's a pinch point. That's limiting our ability to actually coexist and share in the spectrum. So I understand that maybe sometimes you got to match with the important point that Cheryl said, with the technologies and the pieces that are in play globally. But yeah, and sometimes some of that global stuff is actually ahead of us. So how do we deal with that?
Just to one point, and then we'll let my colleague have his time. I'd like to see the DoD really look at their acquisitions roadmap and really understand what needs to be done in the next 5-10 years to their acquisitions. As we've all heard the rumors of AWACS going away. Great, that's one device, and a lot of us in this room are involved in PAS and PAS classified. But let's put it on the DoD to say, hey, we know you've got to modernize. We know you've got some important capabilities that you want to sustain, but put it on a roadmap so that the ecosystem, the commercial ecosystem, can invent around what your needs are. Sorry, Michael, go ahead.
Great.
Okay.
Michael.
Yeah, it's just,
And just as Michael takes up, those of you who have questions, be prepared, because after Michael speaks, you can jump up and ask your questions.
okay. Yeah, I was just, realized, yeah, when you were speaking, that Press Marshall made a great point this morning that I thought, maybe went by too fast as this trade-off between, spectrum and infrastructure. And it's actually, for a number of reasons, much better policy. Not only is it necessary now, but to have low power, small area spectrum access. because not only is high power, wide area this is, for comms, not necessary, not particularly possible with all these bands being occupied, but it's much better policy to really have distributed investment, right? I think Preston referred to how, we moved investment to the home and business. Everyone can buy their own Wi-Fi network and, and have, 80–90% of what they're doing, under their own control. And the same with as IoT progresses, with enterprise. And that's not only going to be that distributed investment is not only going to be probably more doable and efficient, but it can also be updated and customized better. So I think it's not a negative to say that, oh my God, if we have less high power exclusive use, we're going to need more somehow more money for these other things. I mean, it's really good to push it out.
Dennis, can I get one more quick point in?
Well done, well done. I appreciate people who follow through on exactly what they're asked to
He
do.
was just right there waiting, wasn't he?
I'm going to get kicked off the panel because this guy listened to directions.
It should be on. They can turn it on.
I see. Okay, got it. Thank you. Urupunya, thank you so much, your panelists. Really awesome discussions. I'm Urupunya from Idaho National Laboratory. We worried about the security. I'm from the Water Security Institute. But I think a couple of quick things, and really, I think the answer to why we need more spectrum is, to me, very simple, that the world has gone wireless. The amount of data that we have to send over wireless is grown exponentially. And the second thing is that there are a lot of, we're not just connecting our phones now. It's a lot of devices. So it is fueling the internet of, IoTs. So that's one thing. And the second thing is I love the, I think coexistence, I love that too, right? And the coexistence in bands is the future, right? So I think this is very appropriate panel that we need to think about sharing our spectrum or coexisting in the spectrum. There's a lot of need for that. But I think the discussion on UWB, ultra-wideband and Wi-Fi and cellular, the fact is that we'll need all of those, right? The main thing is use case. So UWB use case is location tracking different. Wireless is a lot of data transmission different, right? 5G is where cellular, you need cellular. So I think we need all the use cases that will drive. But again, I worry about security, right? So for this forum, it's shared spectrum or coexistence. When you're coexisting, you're basically widening your attack area a whole lot, right? Others can break the sharing scheme so that nobody can coexist, right? Nobody's using it, or everybody is using it, leading to chaos. So I guess my simple question is, how much do you worry about this coexistence being secure? Thank you.
That's a really great question. So we actually started to address this, and actually it was with the Department of Homeland Security. So they were looking at what they call beyond 5G, beyond your vanilla 5G use cases. And one of the use cases that was studied that we were involved in was looking at the coexistence between 5G and Wi-Fi 6. And there were situations, obviously, and many of you are probably aware of the reports and the findings, that there was definitely issues when you start to bring them together. And even though they are sort of different networks, if you will, they can mingle, and there's ways of making them connect. And the problem is that you have exfiltration, you have infiltration followed by exfiltration followed by security risk. And so that's just an example of a number of different use cases that are being studied right now to look at coexistence and to look at heterogeneous applications and so on. And I'm sure that there are many, many others that we can talk to. But I want to bring up something else that sort of relates to that, if I may, very, very quickly. And I think I speak for everybody, maybe you tell me. But, our mindset has always been kind of vertical. We call it kind of north-south vertical. It's always been kind of like, You create your silo, I'll create mine, and maybe we'll connect somehow underground. I don't know. But the world is becoming more and more flattened. We've known this for years. And we're going to this kind of east-west concept. And this is why the edge is coming out more and more. Edge communications, edge computing, IoT. That's kind of what's driving all this. Going to your point about the tree, I like that analogy actually. The edge devices are actually doing a pull of the technology and maybe a pull of the policy. So I think our policy, our technology is being driven by need, being looked at by modernization. And how that ties into security is because when you start going more and more into the edge or creating the fog out of the cloud, you're creating fault tolerance. You're creating a lot of backup nodes, a lot of things that are out there that you can rely on just in case. If somebody compromises the security of one aspect of the network, you have other aspects that will fill in and take over and preempt the next person, and so on and so forth. I'm oversimplifying that, but you kind of get the notion. So our whole mindset of how the communications landscape is looking is changing very, very rapidly into that. Yeah. And that's a consideration, I think, that we need to be mindful of. So, yeah, there are definitely a lot of things that have to be considered at once. When you talk about coexistence, I think right away about security, and I think about interference. And you think about the dynamics of the process, and at one time or another, you're going to run into interference and contention and security. It's going to happen. How do you predict that? How can you preempt that? And that's what I was trying to say earlier. So, point well taken.
I'm not seeing anyone else. Who else wants to jump up? Oh, you're already up.
I'm already up,
No
yep. Hi, I'm Gordon Beatty. I'm with Viavi, formerly from AT&T for, God knows, 33 years. I was at the labs for a long time. So I've looked at a bunch of problems, and everybody's acknowledged that the workhorse of modern internet is Wi-Fi. And there's a beautiful case in point that that workhorse has been hobbled with respect to 3GPP. And let me give you a simple example. By the way, thank you for the bead money. I live in rural North Florida. Eventually, we'll get that fiber in front of my house lit up. But that's a whole nother conversation. But, you know, today, I'm seeing a couple of things. Number one, T-Mobile service for a cell phone user is virtually non-existent. However, their business service or their residential fixed wireless is excellent, 2,500 megs. It's great stuff. I set it on my porch. Don't ask it to go through the metal lath in my house. It works great. I'm carrying my AT&T core communications, cellular over Wi-Fi, over the T-Mobile, using it essentially as wireless fiber. So that also speculates that the lack of integration of 3GPP with Wi-Fi, and that's just one example of lack of intersection of these silos you guys are talking about, are not matching. Because I can leave my house and migrate to the public AT&T network, which is fantastic in my area. I drive around, I come back into my house, there's no hand in, call drops. So, and that's just a fact. That's just the way the security measures work in those two worlds. Yeah. So my question is, how can we get these, should we say, business organizations that are technology focused, how do we get them in a room, turn off the lights and say, nobody comes out and nobody gets fed until they start talking? I mean, that's literally what it's going to take, I think. And that's just one example. There are other examples of, shall we say, non-cooperation among network technologies. But basically, I think lacking that, you're going to end up with cellular becoming wireless fiber. And people will build their own ecosystems like Apple has, like others have, over top of whatever networks are available. So I'd like your comments on number one and my wish to have 3GPP and the Wi-Fi Alliance tied and put into a dark room somewhere until they come out with an agreement. And the other is, you know, how can we solve the, what I'll call the lack of lack of cooperation and maybe overcomplication. For instance, private Wi-Fi or private cellular is not a well-adopted technology on the part of some of the carriers. So if you want to comment on those two subjects, that'd be great.
So I guess that was, I'll be happy to talk more about that offline, but kind of my immediate reaction is, so what if cellular becomes fiber access? So what, like, we all win, we all have the connectivity, no offense to my other
No, I
panelists,
totally
but so it works, and we have our connectivity. I don't see a problem in that. And then, I think that all these technologies do work well together already today, and we're all working pretty hard, I think, in various other fora to try to do this. I don't really want to get in a room with you, Andy.
I'm not going to be there, don't worry. I'll just stand outside and wait for the, but no, I mean, I don't think, based on my use case of Wi-Fi hand-in, or the lack thereof, I would question your assertion that it works well together. But thank you.
Well, I think there is some work there. This is good. We're actually getting to that terrible time where we do, even though we started a little late, we should end on time for the next group to be on. And I'm looking at Eric down here, who's nodding abundantly. But I do have a final question. As a professor, I have to ask the final exam at the end of the appointed class. So the question is, how many of you learned something based on what you've heard from the panel today? Raise your hand.
Oh, that's awesome.
This was a very, very successful panel. So panelists, you deserve an enormous round of applause.